Hey, good morning, good afternoon, and welcome to our demonstration where we show an OpenShift environment connecting to a Unity storage array using the Dell EMC CSI driver. So, first of all, we have our small RedHat OpenShift environment running using code-ready containers, and we also have our Unisphere array here ready to go. It should be empty. And it's just a virtual machine, so it's small, but it's fully functional. So here you can see the storage array, and you can clearly see that at the moment there's no block volumes and there's no file systems created. So going back to OpenShift, of course we first need to have the CSI driver installed in order for OpenShift to be able to talk down to Unity. So for that we need an operator. And I've already installed an operator, so if you're looking for the operator, you can just go into the operator hub, search for Dell. And in this case, I went with this one with the latest and greatest. You can see that it's already installed, and that should be reflected here, right? So the Dell CSI operator is ready to go. So as you can see, there's multiple arrays supported using the CSI driver, basically all of the leading ones that we have at the moment, and I chose the Unity for the reason that it's available as a virtual machine. So you can see that the Unity piece is already up and running, and we can verify that by looking at through workloads at the pods. So you can see there's 3 pods running. So this is a small environment, so it's only a single node, single Kubernetes node, which is both a controller and worker, which means that we can only have a single controller, so there's no dual or triple controllers that we can do in this environment. And of course there's only a single Unity node, because there's only one node we can actually run containers from. Finally, of course, we have the CSI operator controller manager pod also running. So that basically rounds up the CSI driver installation inside our environment. So I'll just switch to the default project to run some demos. So now that this has been installed, we can actually look at storage, and when I look at storage classes here, we should actually see the storage classes that are provided. So currently we have 3 storage classes. We have iSCSI, we have NFS, and iSCSI topology, which is a more extended case compared to iSCSI, where you may not have the CSI drive installed on all of the worker nodes within a cluster, and then topology is smart enough to know where to place the containers so that they can actually connect. For the purpose of this demo, we'll just be using only iSCSI and NFS. So, looking at persistent volume claims, at the moment we have 0. So let's get started and create one. Create persistent volume claim. We're gonna do iSCSI. We're gonna call it my PVC. Single user access. Let's make it 4 GB in size, and we'll mount it in file system mode. Okay, so now it's being created. If we look at the Unity, we can see that it's already here. So this volume has already been created in order to satisfy this one. So it's bound, and basically it is ready to go. So as you can see now, I accidentally made it 1 GB in size instead of 4. So this is a good opportunity to go straight down to the actions and say, please expand it for me, because I wanted 4, and I thought I typed 4, but anyway. So now the requested capacity is 4, and you can see that very short afterwards, the rest of the system will follow as well. When I look here and I refresh, we should see the same thing. Yes, it's extended to 4 gigs. Okay, so now that we have a PVC, of course we can create a workload. So let's just do a simple deployment, and we'll just create a new deployment that will deploy a single replica Nginx container. I'll replace it with my own code, because of course we need all the Unity specifics in there. So you can see I create a Unity volume based on my PVC. So that's the PVC that I just manually created through the GUI, a single replica, and down here we'll be running a standard Nginx container, and of course we'll be mounting the volume into /export/Nginx. Okay, So let's go and create one. So now the pod is deploying, or actually, well, the single pod is deploying, right? I requested only one, and we can see here that container is creating. I'll just give it a few seconds for it to become available. And as you can see, it just went into the running state, so making it available. So basically what we can do now, we can look into the container and basically access its terminal. So I could just go to the mount point that I said the external storage would be at. I can see it's empty right now. So I could create a file, maybe call it, I don't know, I was here. So you can see now, yes, I created a file that says I was here. Okay, so that's basically the state of this container that I've just created. Okay, so now basically what I could do is I could just accidentally delete this pod. So let's delete the pod, and as you can see, immediately Kubernetes understands that the pod has disappeared, and it has a replica set of 1, so it knows that it needs to create a new one. So immediately it will create a new one, just went into the running state. But the funny part is that the PVC was never deleted. So basically this new container should still have the state of the previous one. So my little file should still be in there. And of course we can verify that. Export slash, I gotta spell it right. And you can see the I was here file is still there, proving that indeed the storage was persistent beyond the life of a container. So more things that we can do with the storage CSI driver is, for example, creating snapshots and cloning. So let's say I want to make a clone of the PVC that I have now. I can simply go here and say, please clone the PVC. All set, ready to go. When I press clone, the CSI driver will shoot a command down to the Unity VSA, ordering it to clone the volume and then surface that volume back up into Kubernetes. So when I go here and I refresh, maybe it's already done. Yes, it's already done. So you can see that we now have 2 volumes, but one volume has a thin clone base based off of the other one, which proves that it's actually a clone. And when I look into the persistent volume claims, I can see that the clone has been created and bound. And of course, I could, in a very similar way to the previous example, connect that into a pod and use it if I wanted to. So this is basically the ability to like expand, clone, snapshot. Of course, we've been doing this all on iSCSI, and we can also do a very similar thing on NFS. So let's try NFS. So Unity NFS, I'll call it my NFS PVC. Let's do shared access, why not, right? It's NFS, so we can do shared access. Let's make it 5 gigs in size, and then I click create. So this takes a little longer, and it has a lot to do with the tiny Unity VSA that I'm running, all right? So this Unity is a virtual machine, which means it's tiny, and creating the operating system takes a very long time. So when I look in files now, it's probably not here exactly, but I can see that there's an active job. And so Kubernetes has actually talked down to the storage array, asking it to create a resource, but as you can see, it's still busy creating the file system. In the virtual edition of the storage array, that takes some time, so I'll just move along, and we'll see that finished later on. For now, I will just go back into the persistent volume claims. You can see NFS is still being constructed, and I'll move on to raw block device. So a raw block device, I'll get it from iSCSI. I call it my raw PVC. Let's make it another 4 gigs in size. Maybe I want shared access because I can have multiple containers connecting into the same disk. And then I'll choose block as the volume mode and create. So basically, similar thing, right? It's all very similar. You can see that the raw PVC is already done, and the NFS one is still pending, so it's still working. So when I look at block, I should have like 3, I think. Yes, so the third one was created, actually being the raw block device. So we could check file as well to see whether that's finished. Yeah, that's finished as well. So you can see CSI Unity, very similar to the iSCSI one, right? The NFS was created equally. So I do have a raw block volume, and of course the next thing we could try is actually to create another deployment, but this time we'll build a deployment that is around the raw block devices. I'll just replace the text with my own version because again I need to make it specifically for Unity. You can see the claim name is my raw PVC, so that's the one that I just created. You can see we still have an Nginx container, but in this case we'll have two replicas because we can have both replicas writing to the same block volume at the same time. So also note that I no longer specify a volume mount but a volume device. So the volume device means that yes, this is a disk and this is not a file export, not a file location. So create that deployment. You can see it's running up from 0 to 2 because I asked for two pods to be in there, and you can see that they're both creating at the moment. So let's just give them a while to go into the running state before I can show you what a disk device actually looks like within the environment. You can see that they've just gone into the running state. So now we'll just open up a terminal into one of them and see what this disk device looks like. So you can see it's sitting in here, right? The device, which is a type of disk. So this basically rounds up the demonstration that I had for you today. Thank you very much for your attention, and if there's any questions, please don't hesitate to reach out to me. Thank you very much.